Now I am. Let's go with it here. So I got one, Pascal, nothing else to do. Pascal was a fun guy. 16th century, he created some crazy stuff. He was in bed rest for 2 years. And he said that God has cursed him because he was devoting too much time to mathematics. So he says, that's it, I'm not going to think of mathematics again. So he started publishing doctrinal works and all that stuff. And then he wakes up one morning and he starts contemplating mathematics. And so we know the Pythagorean theorem. You guys know Pythagorean theorem. If you don't know, you're really in trouble. Oh, sorry. So the shortest path. All right. So the question is this: what's the shortest path? Let's kind of label these guys here real quick. Here, let's label this is A, that's B, and that's C. So the question is, what's the shortest path from B to A? Is the C. Good. So then he has this question. That's cool. That's the shortest path. Now the question is, what's the quickest path? What? What's the quickest path? From A to B. Yeah, so we gotta make this into like a real object here. Ready? So think of a triangle. Think of a triangle against the wall of our classroom, right? And let's say B is on top of the ceiling point. We good? And let's say there's a triangle that's coming down over here where the projector is at, right? So now the question is this: if I have a ball that's sitting up there, and I have a ball that's over here, and I let go of the ball, and the ball is going to start increasing in speed and eventually get to here in 6.2 seconds. We good? So now the question is, okay, what would make it faster? So not shortest, but faster. So would it be like this? So start this guy. That's probably the wrong way, right? That's going to start off so slow and then eventually gain speed. And we're here in 10.5 seconds.
I actually saw this. They went to
Do like a slide shape, so it sounds like it is.
marbles. And my guess was that one was gonna be the fastest.
So yeah, but it has to go to here. So it has to have some kind of horizontal distance, right? And so, yes, you guys are right. If you go like this, gravity takes over first, right? The most amount of gravity takes over, and it's going to go like this. And every skater is happy for Pascal. We good? There it is. Because the drop on a skateboard, right, ramp is usually straight down, right? And then it curves in. Why is that? You gain the most amount of speed going straight down, and then you curve it out to the other side. Okay, so how does he figure it out? He is going crazy because he does this. He says, if I take a ball like this, right? And he starts experimenting with, I'm going to put a little dot right there, right? As I'm spinning this ball around, as this ball is going down this curve right here, I want to know the position of the ball itself, right? So think of the big guy spinning and the little closed dot. Where would that be? And so would it be kind of like something like this? Is that right? Would be something like that.
Yeah.
Right? Where this little black dot would sort of come in and hit the bottom, right? As the ball, and it comes off. And he figures out by that piece right here. Says, you know what? That kind of looks interesting because if I take a look at this piece only, and he starts looking at calculus as well, but he says, okay, if I go backwards in time, that would be the fastest way back. Okay. Again, it's called a solenoid, but he figures it out when he's not supposed to talk about math and think about math because God has cursed him. And he figures out some other stuff. And then then he goes back and he repents of his repentance and he starts learning math, and then he contributes a whole bunch more stuff to mathematics after that. But anyways, Pascal. Do we have a picture of him on there or no? Anybody see a Pascal on there?
What does he look like?
Pascal. He's probably not. Let's see, 1600s. That's right. You guys don't see the names on. Doesn't. He didn't make the list. He did not make the list. Oh no, right here. Long hair. I'm jealous.
That's him? Look at that hair. Look at that hair.
Wow. That's some powerful stuff.
That is powerful. Wow, man.
1623 to 1662.
I mean, for the time, he was all average, yeah.
Wait, how long?
He was doing his whole life.
Oh, 23 to 62, almost 40 years. Looks like died about 39.
I mean, he got
Uh-huh. Hey, good enough.
Basically, he only lived his golden years and then died.
I think that the golden years stop after 25.
Okay, let's do this here. Let's do this Pascal's triangle here that he created. So 1, 2, 1, is that right? Next one, go.
1, 3, 3, 1.
3, 1, uh-huh.
1,
4, 6, 4, 1. 1, 5, 10, 10, 5, 1.
Awesome. Okay. Let's keep on going. Okay, so got to do a few little connections here. So we found out this expands a binomial theorem, right? Let's do this. You guys have calculators? Maybe.
Actually, I'm missing my calculator.
Ooh,
Uh-oh.
that's not good.
It's what he deserved.
So
Maybe one of us invents the time machine at that point. And says, one of us just doing it time.
takes revenge. All right, we good? So let's go with it here. So one thing is, two things together here. We're going to expand binomial theorems some more, right? But we want to be able to go directly to like this number right here, like boom. But we got to be able to make it to that term. Okay, so the other thing that comes out is probabilities. And so if you guys, can you find this little guy in your calculator? It's called combination. It actually comes from statistics. And just see if this kind of connects together here. We won't do statistics though, so not to. Okay, so let me grab my calculator. And I'm going to punch in some numbers here and let's talk about it. Let's see what we get to. Okay, so calculator on. Yes. You guys ready? You guys, I think, have seen this before. Let's see. Let me see if I can test. Yeah. I'm gonna math maybe underneath the math menu somewhere here. Oh yeah, that's so cool. Okay, guys, ready? So going over here, this little math button right here, and this one kind of gives you kind of math functions that are like not normal, you know. And so when you click on here, you have math functions. Hey, look at that. You can turn things into fractions. You can turn things into decimals. You can take the third power if you like. You can take the third. Oh, this is cool, guys. Real quick here. This is called the nth root. So if you're trying to take like the 6th root of 125, you use number 5. You good? So it's all these different functions that you would not normally use. Okay, so that is for math. Yay. Then we got numbers. You can take the absolute value of a number. You can round a number. You can take the imaginary part. You could take the real part. You can take the integer that's the closest to that number. All the good stuff here. Complex numbers. Oh, this is what we need. So, this little button right here. Math is on the third button down. And then come all the way across to probability. I wait until you figure out your calculator.
Is number 4 factorial? It is.
Number 4 is factorial. Absolutely. There is a factorial button.
So we've been just doing the multiplication this whole time.
Oh, gee. Okay, so real quick here. So we got to put a number in first, and let's play with it for a while. I'm going to go back to Pascal's triangle. Where'd we go? There it is. And I'm going to just punch in numbers and see if we can get a connection between this one and this one. So the first number you have to punch in, that's your n value. I don't know what n means, but we'll see. So I'm going to punch in like a 3. And then math. And then what you can do is you can go to the left. Look at that little sneak thing right here. See that? So instead of going across, you just go like here. Number 3.
NPR.
National Public Radio's here too. Okay, I'm going to write like 2, and I'm going to see the answer. Okay, you guys with calculators, go punch in some other numbers. So I have a connection between 3 and 2, and it spits out a 3 for me. So let me. So I'm going to write. I'm going to start writing here, and let's see if we can get a connection here. This guy gives me a 3. Anybody punch in some other numbers here and tell me about them. 4 NCR 5 gets you a 0. Interesting.
5 gets you 0.
Okay. How about do 5 and 5 and 4 and 4? Let's do those. Let's see what that gives us. 5 and 4 is what?
5 and 4 is 5.
5. Okay.
A number and then a number one lower is the first number.
Oh.
Well, but isn't there an equation for it? So that's probably just the equation. I remember reading that in the book.
Yeah. I don't know. How can we systematically do this? You know, we're just kind of randomized
Isn't it
numbers.
like the third row on the Pascal's triangle, like 2?
Oh, cool. Okay, so we have a guess, guys. We have a guess. Elika says it's the 3rd row, but this is kind of funny because that's 1, 2, 3. That's the 4th row.
Is it the 3rd row and then it's it's 1 plus 2, and then the other one is the 4th or the 5th row, and then it's 1 plus 4.
Huh.
Because you do a number. and
Okay, let me see.
And then a number one more than it just get the next number. Like 5 and
Okay,
4,
so
5.
you guys ready? Abby says this, each time you do this here, so 3 NCR or just 3C2. We'll just say it's a little faster. 3C2 is 3. 4C3 is 4. 5C4 is 5. We always get that for some reason. Okay. Is that a 2 or is it a 2? Sorry, what did you punch in? Is that right? Is that what you have? 3, 2, 4, 3?
Yeah,
Or 4, 2?
3, C2 equals 3.
Oh.
4 C5. 5 C4 equals 5. Yeah.
5C4 equals 5. Interesting.
6 C5 equals 6.
Mhm. How about this? Just some kind of systematically. Let's pick one. Those are with calculators here. Can you guys do this here? Let's go. Let's go. 5C1 is Violet. Can you do 5C1? Abby, 5C2. Who else has a calculator coming around? Luke, 5C3.
Wow.
And then come back around to Violet, 5C4. And then Abby, 5C5. Let's just systematically start going through something here.
5C3 is 10. 3rd one on the 5th row is 10. That's how it
5C2 is also 10.
Look.
That's 10.
Dang it.
Well, that
Because there's
5C5 or 5C1.
Yeah, it's not the second.
That's 5. Okay.
And then
The first one
5C4
was
is
a row,
also
the
5.
second one-
5. Okay.
Oh,
So you stick it in a row, but that- there you go.
and 5C5 is 1.
5C5 is 1. Okay. Who has 5C3?
Luke does, and it's-
Luke,
And
10. Oh, we are getting this row, but hold on, we're missing the first one.
What? It's 5C0.
5C0
Oh,
is
gotcha.
1.
5C0.
That's-
And someone check 5C0?
Okay.
Oh,
It's 1.
that was-
It's 1.
Oh, I was right.
Gotcha. Okay. So here's a little thing about Pascal's triangle. This little, if you start counting rows, it's 1, 2, 3. This is 4th row, 5th row. This is technically 6th row. We good? So we kind of think of it 2 different ways. We either just say, you know what, that doesn't count. And we just say, okay, now we can nicely do rows, right? That would be the 1st row. That's the 2nd row, 3rd, 4th, and then 5th. Good there? That's easy enough. And then the weird thing is, yeah, the weird thing is all these guys start off as 0. So you start off with 0 here. So it's 5th row. The first one is the 0th column, right? Or the 0. No. Yeah, this is 1, 2, 3, 4. And then back to 5 gets me back to 1. Not bad. We good there? So now the question is this. Can you guys give me the 15th row? The 10th one in there.
3003.
3003. Cool. Okay, so what would that be? That would be 115, right? And then we go all the way. Awesome. So that would be 1, 2, that'd be 3, 4, 5, 6, 7. That's 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be that guy there. We good? Good there. So far, so good? Jamming. Okay, now the question is this. That's so fun, but how does the calculator calculate all this good stuff here? So now, it just doesn't. Absolutely. So the formula for NCR is, and I gotta just check just to make sure, it's n factorial. Hey, factorial's back over here. N minus r factorial. So we have to do it manually here just for a little bit as well, just so we know. Times another r factorial. So let's go back to what we did before. Let's do, since we did the 5th row, let's do that one. Let's do this one. Let's find this but manually. Let's see if we get the same thing.
Is there like a formula or equation for factorial or
Finding them, there's little shortcuts for them, but there's no like formula for them. Yeah. Oh, you know what? I will let you investigate that. There's a few things there. And we're.
Is this 5 point, or what is this?
9.5. Dun, dun. It's 10. Okay, so let me go back to my Pascal's triangle. And then to go to our, so this guy we got 10. And so Elika says 10. I'm going to go with, this is my N. Come on, little pen, start writing. Five minus 3, and then 3. Five minus 3 is 2, and there's that 3 there. And so then I have to expand everything out. So this is 5 times 4 times 3 times 2 times 1. It's like, do I really have to write down the 1? Uh-huh.
60 times 2 is 120.
Perfect. Awesome. Just a few little things here. It's kind of like, do I write down the 1? Technically, I should because it is down to 1, but then does 1 multiply anything at all? Bless you. No, it doesn't, right? So it's kind of cool. So 2 times 1, 3 times 2 times 1. And I want to show you real quick here. Is there any shortcuts we can do? Can we start scratching out numbers? Yeah, that is gone. So notice that I could actually just do this here. These guys can, or whichever one's the bigger one, right? I can take that out, so then I only have to deal with 5 times 4 and a 2 times 1. A lot easier to deal with than that, and then that's a 10. Okay, so do it the shortcut way. Are you ready? You probably should do it the shortcut way in the next one. 8C3. It's called 8 combination 3. That's what's it called. So I'm thinking in this case, I'm going to actually get rid of the 5 factorial instead of the 3 factorial because it's bigger and I'll have less numbers to deal with. So how about 8 times 7 times 6? And the 5 factorial goes away. Everybody good there? And I'm left with 3 times 2 times 1. And then 3 times 2 and the 6 just go away. 56. Cool. So I found, okay, we good there? So that allows me to find a row and a column really quick as opposed to building my whole triangle all over again each time. That's what that's for. Okay. So far, so good. You guys talk to me. Hawk, you look like you're staring. You have a question. Talk to me. Oh, okay. Well, tell me real quick here, just so we can do this. So I got 8 times 7 times 6, and the rest of it is going to be 5 factorial right here.
Yeah, why do you cross out this? Oh, I see.
No, because that guy there. So these two are just going to cross out. So I don't have to deal with as many numbers. Okay, the other way of writing, Hawk, you good there or no? Okay. The other way of writing combinatorics is this way right here. It's the same thing, just a different notation. If you guys can give me this right here, 7, 4. Same exact thing. It's just a different way of writing it. So the one on top is the n value. The one on the bottom is the r value. And as you do this more and more, it becomes easier because instead of writing 7 minus 4, right, I'm just going to write 3 here, 4 there already, right? I can do subtraction in my head. And I take the biggest one, which is 4 factorial, and I go down to that one, and I do that. That's probably like the easiest way of doing it. Good, good.
And then can't we also take out that 6 and the 2 times 3?
There. And where we're at, 35. Okay, just out of curiosity here, let's see. I'm going to go back to Pascal's triangle. I'm going to row 7, just real quick here. Just want to see if that is all good. Because I did row 6. Didn't we do row 6 over here? Okay, don't need to do it. I'm going to just try to do it here. So this is a 1, 7, 21. Hey, look at that, 35. There's my 35 for row 7. 1, 2, 3. Oh, hold on. It's not that one. Is it? You guys talk to me. It's 1, 2, 3. It's the 4th one in, right? I don't know. Uh-huh. Isn't this 7th row, 4th one in? I'm totally fibbing with you guys here. Just waiting for someone to correct me here. Because we start off with 1 or 0. Yeah, remember, we started with 0, right? So is it the fourth one in or the fifth one in?
It's fourth, because it starts with 0. No, but that was, make it the fifth one, 0, 1, 2, 3, 4. Oh, so it's the third.
It's the fifth one in. Oh man, did I really mess up? Does Pascal mess up?
It's nothing.
Is he all messed up?
0, 1, 2,
I was like.
That's, yeah, that's the 0 right here. All right, that's the 0. That's the 1. That's the 2. That's the 3. Ah ha ha, messing with you guys. That's the fourth one, right? It's still 20 plus 15. Just the other side. Just love messing with you guys. That's it. Okay, boom, boom, boom. I think we're ready, guys. I think we're ready for this. So, exercise 1. We're ready for exercise 1 for today. 45 minutes into class, so we're ready to do exercise 1. In fact, I'm going to try it out just a little bit differently here. Give me some inspiration. Oh yeah. Okay. So can you expand out for me? Oh, let's do the easy one first though. First, x plus y. Sorry, class. 1 second here. I should write the directions here. Expand. That's the directions. A is going to be x plus y to the third. Just do the easy one here. All right, so in my head, what I have is I have that x cubed. So what I have is I have 1, 3, 3, 1 playing out in my head. Everybody agree there? That's the third column excluding the top 1, right? So I know I'm going to have 1 coefficient plus 3 plus 3 plus 1 over here.
X to the third plus 3x squared y.
Yeah, and even easier than that. How about this? Let's do the x's first, then we'll do the y's. So x to the third, x squared, x to the 1, and no x whatsoever. Go back the other way. The first one does not have a y inside it. The second one has a y inside it. Oh, yeah, this one has a y squared and y to the third. And then let's simplify it out. X cubed plus 3x squared y plus 3xy squared. I don't like the way the y looks. Y squared plus y cubed. Done. Are we good? A little bit faster than the box method? I guess so, just a little bit. But when things get complicated, that's when we get some fun. So all yours for this one. Let's go x minus 2y to the third. So now I got some problems here, guys. First things first, I have this little negative or minus sign that's sitting there. So minus is the same thing as negative, is that right? Subtraction, you can add a negative instead of subtracting a positive. So first things first, I'm going to do. I'm going to change this to a plus, and I'm going to make this little 2 a negative. Second of all, what am I thinking in my head? What are the 4 numbers I'm thinking? 1, 3, 3, 1. Perfect. And I'm going to start off like that. 1 plus 3 plus 3 plus 1. You guys talk to me. What's next? X's stuff. X to the third. X squared. X to the 1 and no x whatsoever. The y values. Now this is no longer a y value. It's a negative 2y value because that's your multiplier at the end.
So negative 2y.
First term, nothing. Second term, negative 2y. Second term, negative 2y squared. Are we good? Third term, negative 2y to the third. Can you guys simplify that out?
X to the third minus 6x squared y.
Minus 6x squared y.
Minus 6x1 squared.
Mm-hmm.
Which order we put these exponents? Minus.
So the number in front, the x for this one, all you do is you start off with the highest exponent and you go all the way down to it disappears.
Okay, and then the opposite.
And then you go the opposite way, or you can go, or you start over as like saying the first one is disappeared, then you go 1, 2, 3, 4, all the way to the end.
Okay.
Okay, I'm still looking for third term. Third term.
Minus 2y to the third. Oh, the third term, minus 6xy squared.
Isn't it minus 2, 1 times negative 2y to the third? The last term? Are we talking about the last term?
Second to last.
Oh, then isn't it 3x times negative 2y squared?
Yeah, but what's the simplified form? Because I have a negative 2y that's being squared.
That would be
And then,
negative 4y.
No, just be 4y squared.
oh, wow.
Or looking.
I don't know. Think of it like right over here. What is a negative 2y times a negative 2y?
Oh, yeah.
4y squared times 3x.
Yeah.
4y squared. That's great. It would be 12.
Thank you. I go with that. 12x. Thank you. And at the end,
And then that would be 4 negative 8y.
cubed. Absolutely done. We're good there. There's our expansion. Why do we do this later on in mathematics? Sometimes in calculus, we do expand binomials quite a bit. And this is just a faster, way faster way to expand binomials. Okay. Yours, all yours from beginning to end. C, I need you guys to expand 2x minus 3 to the 4th power. Just to torture you. No other reason. It is music day, so it is appropriate. No, let's just phrase it. So today, finally, it is appropriate.
Okay, so then
Wait, is it just minus 3, it's not y?
What is
It's
it?
raised to the fourth. So now it's 1464.
and then you do the gabagool. Okay, so I'm gonna guess. Looking at this, I'm like, where's the only 3 in this place? The 3's right there, and then it's 3 there.
Why don't we just right out? That was.
That's
Yeah, 4
I was right.
Okay.
That would be
First
2x.
one, 2x.
Put that, put those, yeah.
Okay, got that one. That's gonna be 4 times.
Oh, I
X
understand.
times 4. No,
Oh, it's really so long ago. So start with the X. I don't know.
Room like 4. Okay, it's gonna be 4 and parentheses 2x times negative 3 parentheses.
Well, the exponent thing is so biased, where you start high in the first one, you go down, start low in the second.
I'm just gonna slash.
4.
Just do the 2x.
Done. Easy enough.
Maybe it wasn't.
All right. Raise your hand if you're done. Just a quick little ding, or half raise hand. Okay.
Oh, goodness gracious.
I don't know what the new one is. I'm gonna be honest. I don't know what the new one is, but I know we're out.
All right. Len, done as well? Done as well? Just waiting, getting there. Okay. Okay. Gotcha. Okay.
Oh.
Yes. Uh-huh.
I
No, just put them behind the test.
already turned mine in.
Yeah, whoever wanted to turn them in on Monday did. Yeah. So whoever still wanted extra time.
We turned it on with 3 volts. Oh, I already did.
Calculator.
Mhm.
I don't think I got this right, but you know what? I decided to turn it up. So we're just gonna.
The 9.2 is
Maybe I did turn it on.
Yeah.
Yeah, I graded all of them. So okay, take a look at it. See if there's a.
I have 9.3 back right here.
Because on Friday, you're like, oh, we didn't go over test or like homework questions. So we'll do it on Monday, and then Monday you also didn't go over homework questions.
Yeah.
Got it. So 9.3.
Oh, it's the 9.3.
Gotcha. Okay.
Right, didn't we already turn it?
I thought
I
I
thought
did,
we
but
had.
apparently I didn't.
Hold on.
No,
Okay,
we did.
we'll figure it out.
We turned it in early, because we
Yeah.
said, if you want to.
You could turn it in Monday, but it wasn't.
Because it's at 9.4, did it?
No.
It's all right. I don't think it should be because we just barely finished.
Yeah,
9.4.
9.3 is due
Did I
today.
do that?
Yes, we figured that we didn't know 9.4. Yeah.
Uh-huh.
No, I remember.
So let's do this here. If you have not turned in 9.3 today, you can turn in 9.3. Do we need to go any homework questions off 9.3? So I can. Okay, see if you can find a little. Okay, you guys ready for this? Let's go with it here. So in my mind, I say 1, what, 4, what? 6, 4, 1. Perfect. Okay, so 1. I need more room. I'm gonna go down here. 1 plus 4 plus 6 plus 4 plus 1. Cool.
Yeah, we got that one.
Cool. Next one is. All right.
So the first one is 1 times 2x.
Yeah. Well, let's see. First one is no 2x whatsoever, right? First term. Second term is going to be 2x. Oh, ouch.
No, we're already gone.
Nah, just kidding. Just messing with you guys.
Oh.
It started with the highest x quoted for the first
So,
one.
2x to the 4.
Oh,
I didn't wait a long
I
time.
That's so mean.
3, 2, 1, and then nothing, right?
Oh, okay.
Yeah.
Okay, how about the minus sign?
Yeah, okay.
Careful with the minus sign.
Starting on the.
Second one, yes. So the first one, the -3 is skipped. This is -3 to the 1, -3 to the 2.
Oh my God, I got it
-3
right.
to the 3,
I cannot believe
3
that.
to the
I think
4.
But I got.
Okay.
Joy.
That's sad.
Final
Well,
answer.
just
Anybody?
help by multiplying,
No.
right?
Anybody have a final answer? Confident of it? Go ahead. Go ahead,
Well, I'm
Abby.
not confident of it. That's kind of a big ask, but I have 2x to the 4.
Yeah, hold on, but you have to expand it out though. What is
Oh,
2x
right.
times 2x?
Expand that. So the first one is 2x to the 4.
Oh, yeah. So 2 times 2 is 4. Another 2 is 16. 16 x to the 4th.
Oh, I forgot to do x to that one.
Mhm.
Never mind. It's one.
That's okay. No problem. What is that? That is going to be, I'm going to do the exponent first. That's 2 times 2 times 2.
I forgot to.
Did I
do
get
x
it?
to
Minus
the 4th, right?
I got that. Yeah.
Oh, wait, did I get it
Minus
right?
96.
Probably.
Never mind.
X to the 3. Next one. Oh, even bigger. There we go.
Whatever -27.
Oh,
times
you have to
4
do by
times 6 is-
-3 as well. Oh, I
Negative
forgot
7.
that.
-27. Wait, no. You do freaking, oh, that's just.
I'm gonna go off the side.
9 times -18 times
Wait.
4. How much it is?
I don't think so. That's still too small, I think.
I got
4
16.
times 6, 36 times 6, which I don't know what that is.
240, let's see, it's that's 224, right? And 9 is almost close to 10, so that's 240 minus 24. Oh, that's so cool. Some crazy math. Is that right?
Yeah, I was right. I don't know. 36 times 6. I was right.
I forgot to do the exponents here. So it's 116?
216?
Oh, yeah, 216.
216. Are you okay with 216? And let's see, I got x to the second this time. Okay, and I think we're this one now. That's going to be that's 8 times 27. I think so, right? Is it 8 times 27?
60 plus.
And it's a negative as well.
What's 8 times 7? 56.
56.
It's 6 and that's.
That's a rather
Wait, 8 times
large
27.
number.
16 plus 5 is
Uh-huh.
16.
It's 216.
Violet says 216.
Oh, no, it's not.
56.
I don't know why they don't punch it into the calculator either. Violet, but we'll just wait for people to get there.
Yeah.
16, I guess.
216? All right.
So it's
And that's
216. Yeah, bye. Let's go.
Does it have an X or does it not have an X?
Probably. It has.
It has an
one
X.
X.
Yeah, no, that's.
1X. Okay, and last one. -3 times -3 times -3 times -3.
81.
81.
We do one more.
One more. All right, I'm not gonna take it to the 4th power this time. That's crazy. So let's take it to the 3rd power. Oh, this is fun. I'm gonna go like this.
Oh.
Oh,
Oh, I see what
guys,
you
I'm
did there.
sorry. I shouldn't have
Yeah.
asked. Don't ask Corey.
Slide is always an option.
It's not
Wait,
bad.
okay.
Yeah, sure. Guys, I'm gonna go back one slide real quickly here just to get answers.
3.
Oh, I won't. Oh, I actually. Wait, okay.
I'm trying to remember. You add.
All right, give you guys some time doing that here. Did want to ask you, do we have homework questions from 9-3? I want to handle those before the end of class. Do we have?
Too late.
I turned that.
Yeah, already forgot. 59, okay. We'll handle that then.
Oh, yeah. I'm just kidding.
Cool. I'll have to leave some time for that question towards the end. Okay, Landon, are we good to go on to the next one?
Oh, yeah.
Doo-doo.
To this? To what? Oh, how did it started? I
haven't even written it down yet.
was talking about the.
All right, in my mind, I think 1, 3, 3, 1.
Yeah, I think that's well. I got
One.
that far.
Plus 3, plus 3, plus 1.
1 x to the 5th. I think because it's 3 plus 2.
Oh, it's,
Anybody give me the next portion of it?
3 times x squared plus 7.
what?
It's the one in,
4.
hold on a second, it's the one in front though, right? Is it this right here to the, that?
Oh, I thought you meant the second one.
Oh, gotcha, okay, the second one would be,
3 times x squared to the second.
uh-huh,
Okay, oh.
this would
And
be
then x squared.
the 1, right? And then it's nothing at that point. Good there. Going backwards here, first one is skipped.
Yeah, and then it's just 4.
4. I'll just I like write 4 to the 1 because then I can
Four to
have
the second, and then four to the third.
sweet. Okay, done. And final answer.
What color exponents you just add, okay?
Mhm.
Okay.
Oh, hold on real quick. Sorry.
Well,
So let's go with exponent rules. If you have an exponent on inside of a parenthesis and the outside of the parenthesis, it is this right here.
Yeah.
If you have,
X to the 6.
okay,
Well, X to the 4. There, that's.
okay. Okay, I'll keep that in mind.
so
So then it's
x to the 6th, next. Plus 12x to the 4th.
16.
48, try to find something real quick here.
64.
64, I agree with. Ooh.
That was much easier.
Okay, good. At least a little practice in there. Okay. Next, we are example number 2 finally. Oh yeah, sure. Yep, sorry, going back real quickly here. Example number 2. Okay, guys, ready? Find the 6th term of x plus 2y to the 8th.
Oh, the 6th term. So if we brought out all the exponents, then we're getting
Yeah, so the first one, second one, third one, 6th one.
Like scary.
Six, that is just one.
Da da da
So it
da.
would be
That's my
Two
daughter's name.
Y
J.
eight.
And then I got a
Two to-
freaking bracelet.
what's two to the
I
eight?
don't know, I mean,
Two to
yeah,
the eight.
exactly. But
Well,
then one of something messed up.
no, I like doing things in my
She's
head.
gotta
It's
change
256.
her name.
I would've done that,
but it would've taken too long.
256 Y to the 8.
Say again.
256 Y to the 8.
Whoa, that is so cool. Okay. No.
You forgot the X.
But she also.
But it's the 6th term.
And I don't.
And the 6th term of it is just the 1 because the.
No, it's 8. It's only the last term that doesn't have the X. So this would be X.
I know, because it's 8.
No one's getting it.
Oh, wait, yeah.
Yeah.
All right, let's do this one together. Guys, let's go with it. Let's do this one together.
X squared, right?
This would have, I don't know, let's just try it. I don't even know
Yes,
the
it
answer
would.
to it yet. So first things first. First things first is, you know that little C thing that we were doing, the combination stuff? I think we might have to do that. So if I'm thinking about the terms here, the 6th term is going to be 1, 2, 3, 4, 5, 6. Is that right?
Yeah.
So we're on the 8th row. But remember, these guys are 8C0. Is that right?
8C0.
So this is 1, 2. Oh, 5. So we actually need 8C5 as our coefficient. We're good. That's gonna be the little number that we multiply by, right? That's our little 1331 or 14641, right? So I have this guy. It's gonna be 8C5. Are we good there? Okay, next. So then what happens to the x to the 8th? This becomes, this would be x to the 8th here, is that right? This would be x to the 7th, to the 6th, 5th, 4th. This would be 3rd, is that right? It would be x, should be an x to the 3rd. You guys talk to me just for a little bit here. If I'm taking powers of 8, right? This would be 8. This would be 7. This would be 6. 5, 4, this would be 3, but let's connect the 3. Isn't that just 8 minus 5? That's just 8 minus 5, huh? Interesting. Okay, so it'd be x to the 3rd, which technically is just 8 minus 5. That's how we got that guy. And the way we got the number 5 was what? it was the term, right? This R value was term minus 1, is that right? We wanted the 6th term, but we're gonna do 5. Okay, and then what are we gonna do over here? I'm gonna go with this one. I'm gonna go with just the 5 itself. We good? Remember how the first term does not have it in there, right? Remember when we do this here? If this was a 2x or 2y, this would not have 2y in it. This one would have the 2y to the first. This would have 2y to the second. This would have 2y to the third, 2y to the fourth, and voila. This is 2y to the 5th, which matches up with this guy again. We're good. So notice how these all match up. This is the only one that we got to be careful for right here, is this subtraction between the two. But I think we got it. Anybody with the calculator real quick here? Give me 8C5. 56. Boom. X to the 3rd. And then what is this? 32. Is that right? Y to the 5th. And then anybody 56 times 32. Say again?
1,792.
92 x cubed y to the 5th, and got it. So I'm looking just for that particular term. Okay, I think that is it right there. All right, someone's being excited. Okay, I'm gonna stop there. This is the end of 9.5.
You already finished 9.5.
The end.
What about 9.4?
Guys,
So
9.4
we
is
just
what-
finished 9.5. We haven't turned in 9, or some of us haven't turned in 9.3, and then we have 9.
But with the time remaining, we're gonna go
Because we
to
spent 3 days on 9.4 because it's horrible.
9.3 homework. We're gonna just tackle one homework problem real quickly here before we turn it in, which is 59, I believe. Anybody else have another question? So we had one question come up. This is this right here. It's the summation all the way to 6 of 32, 1/4 to the I minus 1. Okay, so there's like a little formula in 9.4. It says this. It says if you're trying to get the sum of I is equal to 1 to n of a sub 1 r to the I minus 1. Oh, yeah. I don't know because anybody answer 59?
It was 42.256.
Oh, 0.256. Okay, let's take a look at the formula real quick here and put it together. So this is a sub 1. This is gonna be 1 minus r to the n divided by 1 minus r. So in this case, it's gonna be 32. It will be 1 minus 1/4 to the 6th power over 1 minus 1/4. And then whatever you get for that. Okay, with that, if you guys could put your 9.3 homework right over there on your way out. And test corrections, yes.